Hello, today we're going to talk about coupled reactions in terms of thermodynamics. So when you couple a reaction, you're taking two or more reactions, putting them together in order to make an overall reaction that is thermodynamically favorable. This is a similar process to what we did in Unit 6 with Hess's law. So if you have something like A plus B yields D, and you have D plus C yields E, and if you add those two reactions together, the D's will cancel as an intermediate, and you will be left with A plus B plus C yields E. Here, we're adding in an extra layer of looking at the free energy change. So maybe the delta G for this reaction is positive 50, and the delta G for this other reaction is negative 100. So the second reaction is already thermodynamically favorable. We have a negative delta G, but the first reaction is not. We can get the first reaction to happen by coupling it with the second reaction. And when you add those two reactions together, you can also add their values of delta G. And so overall, the delta G would be negative 50, which is thermodynamically favorable because it's negative. So that's kind of the rationale of coupling some reactions together. Also, if you need to multiply a whole reaction by a particular factor, you would also multiply the value of free energy by that factor. So if I needed to multiply this one by 2, I would also multiply delta G by 2, or you can multiply the whole thing by 1/2, or whatever it is. You can do that just like with Hess's law. Okay, so here we have two reactions, and the question wants us to write the overall. Let's do that first. So if we add the reactions together, A2 is an intermediate, so we have A2B3 plus C yields 3B plus A2C, and so we can also add their delta G values. 150 plus negative 120 gives us an overall delta G of 30 kilojoules. And so it says, would the reaction shown be a good example of a coupled reaction? No, it would not be a good example because the value of delta G when you put them together is positive overall, which is not thermodynamically favorable. Okay, so given the following reaction, is this reaction thermodynamically favorable? No, because it has a positive value for delta G. If this reaction was coupled with this other reaction here, would the coupled reaction be favorable? Right, so show the overall reaction without oxygen and calculate delta G to support your answer. So without oxygen, we want to cancel out the oxygen. We have 1 oxygen on the product side, 1/2 oxygen on the reactant side. So we need to multiply this reaction and the delta G by 2. So I would wind up with 2 carbon plus O2 yields 2 CO2. And then my delta G when I multiply by 2 is negative 274.6. So if I write the overall equation, all of the reactants together, 2Ag2O plus 2C, the oxygen cancels out, yields 4 silver and 2 CO2. And my overall delta G, I can add up the two together to get a negative 252.7. So yes, the coupled reaction would be favorable because it has a negative delta G overall.